Number 2, lesson 3-6, quadratic formula, example 5, which is the last example. Use the discriminant to find a particular equation. What values of b will cause 2x squared plus bx plus 18 equals 0 to have one real solution? So we learned about discriminant in example 3, and we learned how to interpret that in a context in example 4. So we'll look at the discriminant again. When we're talking about the solutions, the type of solutions, one real solution, how many solutions we're going to have for quadratics, that's when we will use discriminant, and we're going to talk about discriminant, right? So in this example, we're going to use the discriminant to find a particular equation. So again, we have this equation where we don't know what b is going to be, but we know that we want it to have one real solution. That means the discriminant has to equal to 0, right? So then we have to remember what the discriminant was. It's the radicand in the square root of your quadratic formula. B squared minus 4ac is the discriminant, right? So we want to let the discriminant equal to 0. So b squared minus 4ac is 0. And then we want to solve for b because we don't know what b is, but we know what a and c are. So figure out b by plugging in a and c. 2 times 18, and that's equal to 0. And then you just solve for b. B squared is equal to 144. And so if you square root both sides, you will have plus or minus 12. So your b could either be a positive 12 or a negative 12. There could be two different solutions because why? B is a square. Is squared, right? So this equation itself is a quadratic equation where we're solving for b, which means you would probably have two different answers most of the time. So there are two possible equations where b is positive 12 or b is negative 12, right? So you can rewrite this equation with b with positive 12 and with b being a negative 12. So 2x squared plus 12x plus 18 is equal to 0, and 2x squared minus 12x plus 18 equal to 0 would be possibilities. So let's look at try number 5. Determine the values of b that ensure that this equation 5x squared plus bx plus 5 equals 0 has two non-real solutions. Okay, so again, there may or may not be two solutions. There may be more than two solutions. There may be more than there would be a lot of equations that would be possible if you were to find an equation that has two non-real solutions, because your discriminant is always going to be negative. So pause the video and see if you can figure this out by yourself, and come back when you're ready for answers. Okay, are you ready? All right, so think about your discriminant. When you have two non-real solutions, what do you have for a discriminant? Your discriminant is a negative number. So your discriminant is anything less than 0. So it's not negative 1, it's not negative 2. You don't know what it's going to be, but anything that's a negative number works, right? So we have to solve an inequality in this case. D could be anything less than 0. So we're going to write the discriminant equation. B squared minus 4ac could be less than 0. And so first identify your a, b, and c. A is 5. B you don't know. C is 5. And so plug in what you know. B squared minus 4 times 5 times 5 should be less than 0. Right? And then you solve for b. B squared minus 100 is less than 0. And so b squared, if you add 100 on both sides, you'll get less than a positive 100. And so if you solve for this inequality, you square root both sides, but then you have plus or minus 100, but you have an inequality. What do? So first, let's look at this question, okay? You have less than plus or minus square root 100, which is 10. So this will divide into two inequalities, right? Where this is a compound inequality, right? So this is your original equation. So this step is actually not yet done. This step needs to go right here. This is something that you should think about in your mind, but even before you write plus or minus, you need to rewrite this into two separate inequalities. So if you are not sure how compound inequality works, then you need to go back and review the rules of inequalities for compound inequalities. So when you have b squared less than 100, you can either keep your sign and with your inequality sign and your sign of this number, but you can square root, right? So it's going to be less than 10, right? But then when it becomes negative, then you're changing your original positive 100 into a negative. So that means you have to change your inequality sign. So b is greater than negative 10. So this is a compound inequality where these are combined together. So b has to be anything less than 10 and anything greater than negative 10. If it goes outside that boundary, then you would either have two non-real solutions, and if it's exactly 10 or negative 10, you would have exactly 0. So then you would have one solution, right? So anything less than 10 and greater than negative 10 would work. So first of all, let's write the compound inequality. b is greater than 10 and less than 10, but yeah, you didn't have to write the possible equations. You just had to determine the values of b. So this is all you need to do. All right, so that was example 5 and try 5, determining the possible equations using our discriminant. So let's wrap up our lesson. So the concept summary of this lesson, key features of the quadratic formula, includes the quadratic formula. So remember that your quadratic formula works in any type of quadratics. So it could give you non-real solutions. So that's why it works all the time. So if your other methods like solving by graphing, solving by grouping, factoring by grouping, right? So those methods are great, but if that doesn't work, you need to use a quadratic formula. So usually you're using quadratic formula for complicated equations, quadratic formula for complicated equations where it's not really obvious that the solutions would be real, or if any other method doesn't work. So using the discriminant is also a very important concept. So remember that when the discriminant is positive, you have two real solutions. When discriminant is 0, you have one real solution. When discriminant is negative, then you have two non-real solutions. It doesn't show in the graph, but it's because they're complex numbers, and you can't really see it, right? Because it's not real. They're imaginary numbers. Yeah, so that was lesson 3-6 about the quadratic formula. Thanks, guys. I'll see you in the next video and with the next lesson.